Okay.
Okay. Yeah, I can unmute myself. Thank you for coming, Professor Grossberg. I just want to start by asking a few clarifying questions to make sure we're on the same page. So the first, and my name is Chris. So I'm computer science going to a PhD program at UChicago. So closer to you than Seattle, right? The first one is I just want to understand, but it seems like art, right? We're focusing on art for this, but maybe also the majority of your work talks about understanding the brain and creating these theories for it. And then there's the underlying principle where if you can effectively model the brain, right, you can effectively model learning systems, right? And so then that's why you're making the comparison of art not only as a neuroscientific theory, but also as a comparison to deep learning. Is that accurate?
I start by trying to understand hundreds of psychological experiments about many different aspects of our behavior. I'm mostly interested in things like learning because I believe that the developmental and learning processes have a rate limiting role in our biological intelligence, so that, for example, you can learn a category that'll recognize a letter using the same dynamics as a category that'll recognize a word. So there's a great parsimony in these circuits. Now, could you repeat your question in the light of that?
I think my key question is, it's for
deep learning. I couldn't care less about deep learning. Deep learning is a fad, and backprop got very popular. Well, first, backprop was popularized by Rummel, Hart, Hinton, and Williams in 1986. To hear them talk, you'd never realize they didn't discover it. It was discovered by Shinichi Amari, David Parker, and Paul Werbos. Paul Werbos did his PhD thesis on it in the 1970s. They just popularized it, and they developed some applications. So it became popular for a while again until people realized its problems. Very, very slow learning, catastrophic forgetting, no internal representation because it's just basically a feed-forward adaptive filter, no intelligence. So it stopped being popular, it faded, and lots of other models became more popular. But then, in the interim, two things happened. One is, due to the World Wide Web, there were huge databases that you could Google, like millions of pictures of cats. And the speed of computers and computer networks became blindingly fast, so that now I carry a supercomputer in my pocket. But you put together rooms full of these things and you get a blistering speed of computation. Huge databases, very fast computation. So suddenly you could train a backprop network or a backprop on steroids deep learning on 100 million pictures of cats, and you put in a picture of a cat and out would come cat. And this was supposed to be some exciting thing. Well, in the field of neural networks, which I founded, that's a joke. Okay, so now you want to repeat your question?
Well, I think what I'm interested in is you say that you couldn't care less about deep learning, right? And you say it's a fad, right? As a computer scientist, that's really, I'm sorry.
I don't care about it because it is a very weak, damaged model that teaches me nothing that I want to know. That doesn't mean...
As a neuroscientist.
No, no.
As a what then?
the leading technical modeler of biological intelligence. I don't think it's bad if people take a deep learning package off the shelf and it helps them through, if you have stationary data and a lot of it, and you do offline learning, you can get it to learn some predictions, and then you can put it, hardwire it into your iPhone or whatever. It can be useful. Use it. That's fine. Anything that's useful, use it. But don't delude yourself about what it is. You have to know the strengths and weaknesses of the models you use, including mine. So what I find objectionable is the sheer intellectual dishonesty of how some people describe the significance of deep learning. They never compare it with other models in comparative benchmarks. When Gail Carpenter and I introduced various art algorithms for applications, we benchmarked it against every available popular model, including backpropagation, which we blew out of the water. Now, I'm not going to spend the rest of my life benchmarking the models I developed because they're used by thousands of people who know their provable properties. For example, in 1987, Gail Carpenter and I proved a complete set of theorems about how Art 1 learns, and they're reviewed briefly in my book, including that it doesn't experience catastrophic forgetting, that there are situations where you can learn a whole database on a single learning trial in a self-stabilizing way. So because of these things, deep learning and backprop teach me nothing. And I know Paul Werbos. I knew Frank Rosenblatt. I thought highly of Frank. I like Paul, and I think he's an authentic scientist. I don't need them to understand what I want to know. I know more than that. That's why I don't care.
So let me make sure I understand that. Then what you're saying is that for you, deep learning it has like the signal to noise ratio, right? There's a lot of dishonesty about its application, right? And you're not opposed to the methods, but can I I'm sorry, can I finish before, because I feel like there's a disconnect somewhere. So to clarify, it sounds like what you're saying is that again, you're not opposed to those methods. They just don't teach you anything, right? But if there's value in them, for example, for converting speech to text, or for recognizing a cat image, you're fine with that, right?
Why shouldn't I be? I'm a technologist.
So then, okay.
The problem I have is that people who use it should understand the range of applicability. And I've heard a number of people, I don't look for them, saying, oh my God, it crashed. Now, certainly if you do it offline and you're careful, and if it crashes, you do it again and again and again until you get the criterion, and then you freeze the weights. Okay, good. One issue, though, is scalability. So catastrophic forgetting is much, much more likely if you have inputs that are dense in the vector space of inputs. And one way to avoid that is to sparsify the network, which means you have millions and millions of nodes or hundreds and hundreds of layers, which is what they've done. That's very inefficient. You don't have to do that in algorithms that self-stabilize their learning. If you look at our brain, we don't have 100, like I think I have a figure of a deep learning net with 100 layers. We don't have 100 layers in our whole brain, let alone for classification and prediction. I mean, you should give that some thought. But the reason I'm concerned is just I want people who use it to know it's untrustworthy and unreliable in a very specific scientific sense. The fact that it's not always presented with those facts in mind, I think is unfortunate for the youth, to the user community. You might want to call it intellectually dishonest. For some people, that's true. For other people, it may just be they don't really know.